Hello guys, welcome back. In this video, we're talking about Frobenius method, one of the methods to solve power series solution of O.D.E. Now, this is the formula: y equals to x raised power c in brackets a naught plus a1x plus a2x squared plus a3x squared plus and so on and so on ar x raised power r, where a naught is the first coefficient that is not zero. Now, let's take a look at the steps that we need to take. To solve a given equation, we have to find the coefficients of a naught, a1, a2, and so on. Now, we need to get the index c in the trial solution. These are the steps to take if we want to solve differential equation or using Frobenius method. The first one is to differentiate the trial series as required. Now, the second is to substitute the series in the given differential equation. And the third is to equate the coefficients of the corresponding power of x on each side of the equation. So this is our trial series. This equation here is our trial series. Now, let's go. Example 1. First thing to do is to rewrite. So we're going to have 2x y prime prime plus y prime plus y to equals to 0. That's the first thing to rewrite. Now let's write out our trial series, the form of the theorem, which is xc in brackets a naught plus a1x plus a2x squared plus dash 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 ar x raised power r. Now you can see that I did not write a3. Now it's not necessary to write a3, a4, a5. What you need is this first one, which is the a naught, and this last one. That's what you need. That's what you'll be working on. Because I will explain further as we are moving on. Now let's open up the brackets. We have a naught x raised power c. We are going to use this x raised power c to open up the brackets. So for the second one, we have a naught a raised power a1 x raised power c plus 1, then plus a2 x raised power c plus 2 plus this one be ar x raised power c plus r. How is it like that? If you remember indices, now we remember our indices when you have x raised power a multiplied by x raised power b, which is the same thing as x raised power a plus b. So that's what we did here. We have c raised power c x raised power c multiplied by x, which is x raised power 1. So we're going to have x raised power c plus 1. So that's what happened here, here, and here. So let's move further. Now, this is our y. In this our question here, we have y prime, and y prime prime. So we've gotten our y. Let's go to y prime. Y prime means we have to differentiate this. So if I differentiate this, I will have a naught c x raised power c minus 1 plus a1 c plus 1 x raised power c plus a2 c plus 2 x raised power c minus 1 plus 1 plus ar c plus r x raised power c plus r minus 1. So this is for our first derivative of y. Now the second, which is y prime prime, so we have a naught c minus 1 x raised power c minus 2 plus a1 c plus 1 c, x raised to power c minus 1. This is minus 1. Then plus a2 c plus 2 x raised to power, no, this c also come down, c plus 1 x raised to power c, because if minus 1 from here, so it will just remain c plus ar c plus r. Then this one will come down, c plus r minus 1. So we have x raised to power c plus r minus 2. So this is for our second y. So we are done with our first step, which is we have to differentiate the trials. Now let's go to the second step. Substitute the result in the given differential equation. Now we have to substitute this into this. Now if we are to substitute this into this, the equation will be long, because I have y prime prime. If I put it here, then plus y prime, I put it here, y, I put it here, we have long equation. So we have 2x y prime prime. So which means that we have to multiply our y prime prime, which is this. We want to multiply our y prime prime by 2x. So if I multiply by 2x, I will have 2 a naught c minus 1 x raised to power c minus 1 plus, now there is one x here and we have minus 2 here, so we have minus 2 plus 1. So that's that, I have minus 1. Now plus 2 a1 c plus 1 c x raised to power c minus 1 plus 2 a2 c plus 2 c plus 1. Then this will be x raised to power c plus 1 plus a2 ar c plus r c plus r minus 1 x raised to power c plus r minus 1. So that's for that one. Now y prime, there is no coefficient. There is no coefficient for y prime and there is no coefficient for y. So we just need to rewrite them. So we're going to have a naught c x raised to power c minus 1 plus a1 c plus 1 x raised to power c plus a2 c plus 2 x raised to power c plus 1 plus ar plus 1 minus 1. Now we are done with this step. Now the next step is to substitute, is to find the coefficient of the x. Now remember I told you in the first video, we said we need only this a naught here and this ar. That's only what we need. So you can find a1, you can find a2 too, but ar can give you a1, a2. So let's go. Now from this first one, which is for the a naught, the least power of x is x raised to power c minus 1. So let's find the coefficient. The coefficient of x raised to power c minus 1. Now from the first one, we have 2 a naught c minus 1 From the second one plus A naught C, that's for the second one, all equals to 0. Now I can see that A naught is common, C is also common. So you're going to have 2C minus 1 plus 1 equals to 0. So if I open up the bracket, so you're going to have 2C minus 2 plus 1 equals to 0, and A naught C 2C minus 1 equals to 0. Now remember we said where A naught cannot be 0, so we're going to have C 2C minus 1 equals to 0. C equals to 0, or 2C minus 1 equals to 0. So which give us C equals to 0, or C equals to 1 over 2. So that's for the first one. Now for the second one, we go to when the coefficient of x raised to c plus r. Now if we go back, we're going to see that we have this from this last part. Now from here we have these things, so we're going to write them out. So from equation 2 xy prime prime, we have 2ar c plus r minus 1 x raised to power c plus r minus 1. From y prime we have ar c plus r x raised to power c plus r minus 1. From y we have ar x raised to power c plus r. Now remember we said the coefficient of x raised to power c plus r. So it's like we are having 2 meter here. This one is 2 millimeter. This one is 2 millimeter. And we need our answer in meter to be a meter. So we need to convert this to meter. Do you get? So that's the idea that we have. We're going to put in our mind, since we are looking for x raised to power c plus r, and this one is minus 1. So we just assume that this is a millimeter, this is meter. So we need our answer to be in meter. So we need to convert this to meter, Now we have minus 1. How can I cancel this minus 1? By adding plus 1 to it, right? It's by adding plus 1 to it. But I can just put in the plus 1. So there must be a means that the plus 1 must come inside. Now we now say let r equals to r plus 1. You know, if r is r plus 1, if I put it here, my r is only 1 that I want to cancel. And if r is r plus 1, r will still remain. So I hope we get the logic. So from here, we're going to have 2. There is r here. Anywhere you see r, you're going to put r plus 1. Now, the next one, we have c plus r. There is r here, so that will be r plus 1. The next one, there is r plus 1 here. So r plus 1. So this one, we cancel this one. So we are going to have c plus r only. Then this one will be x raised to power c plus r. So that plus 1 will cancel this one. Now from this second part, we have ar plus 1, c plus r plus 1, x raised to power c plus r. Now this one is already in what we need, so we don't need to convert that one. Now let's take the coefficients out. So we have 2ar plus 1, c plus r plus 1, c plus r, that's the coefficient from the first one, plus the second one, ar plus 1, c plus r plus 1, that's the coefficient for the second one. For the third one, we have ar, which equals to 0. Now we can see that ar plus 1 is common, then c plus r plus 1 is also common. So let's factorize it out. So it remains c plus r plus 1. Now it remains 2 and d, so you have 2 c plus r. It remaining 1 here. Now take this to the other side. We have minus ar. Now it will be ar plus 1, 2c, sorry, 2 plus c plus r plus 1. If I open the bracket, I will have 2c plus 2r plus 1 equals to minus ar. Now remember, we got two value for c equals to 0, c equals to 1 over 2. So let's start with when c equals to 0. So when c equals to 0, so if I put c here, so I have ar plus 1. If I put a 0 here, so we have a 0 plus r plus 1, 2 multiplied by 0 plus 2r plus 1 equals to minus ar. Ar plus 1 equals to r plus 1. Then this will be 2r plus 1 equals to minus ar. I hope you understand. If there is any question, you can type it in the comment section. Then I will come back to explain. Now the next step is to divide both sides. We have to divide both sides by r plus 1, 2r plus 1. That's the next step. So if I divide both sides by r plus 1, so I'm going to have ar plus 1 equal to minus ar over r plus 1, 2r plus 1. That's what we're going to have. Now, the next one is to say, find an appropriate value to put. So let me write what we have here. So we have ar plus 1 equal to minus ar over r plus 1, 2r plus 1. Now we can say let r equals to 0. So if r equals to 0, so you have a1 equal to, so let's move on. It will be minus a0 over, so if I put 0 here, we have 1 multiplied by, if I put 0 here, 2 multiplied by 0 is 0 plus 1, so you have 1. Now when r equals to 1, if I put 1 here, I have 2 equals to minus a1 over, if I put 1 here, so that will be 2, then 2 times 1 plus 1, so that will be 3. Well, when r equals to 2 now, we're going to have a3 equal to minus a2 now over, so 2 plus 1, so we have 3 multiplied by 2 times 2, 4, that's 5. Now when r equals to 3, so you're going to have 3 plus 1, so you have 4 minus a3 over 4 multiplied by 7, 3 times 2 plus 1. Now we need to find, we've gotten 4 series now. 1, 2, 3, 4 is okay. The standard is to find 6 series, but 4 series is okay because of time and others when you're solving it in your exam. So we need for just for series is okay. So I need every order here to be in form of A naught. So we have to convert everything to be in form of A naught. So this is already in A naught. So we need to convert this. So which give us, if I put here, no, this is A1, then what's your A1 here? This. So let's put our A1 here. So that will be minus A naught over 1 times 1. Then this one will be 2 times 3. So which is the same thing as A naught over 2 times 3. Now this is 1. 1 times 1 is 1. So you can just say it's 2 times 3 to cut the equation short. Now when you get to A3, A3 is minus A2 over 3 times 5. Then what's our A2? This is our A2. So that will be minus A naught over 2 times 3. Then 3 times 5. That is for that. Now let's go to A4. A4 is minus A3. So if I put A3 here, so minus we cancel out minus. So we have, okay, let me just write it. 2 times 3, 3 times 5, and 4 times 7, which is equivalent to minus cancel minus. So you're going to have 2 times 3 times 4 times 3 times 4, then 3 times 5 times 7. The reason we are putting it this way is to put it in form of factorial. You know, we can call this 4 factorial, this one to be in 2 factorial. So that's it. This we are writing it there. Now remember our equation that says y equals to x raised power c a naught plus a1x plus a2x squared plus a3x cubed plus a4 x raised power 4. Now we're going to stop at this because this is where our a4 is. Now let's put in the value. Now we now say when x equals to 0, remember it was when x equals to 0 we got all this value. So our a naught remain constant. Now what is the a1? A1 is minus a naught. So just write minus a naught x. That's our a1. Now what is a2? This is a2. So that's plus a2 x squared over 2 times 3. Now what is a3? A3 is this. So you have minus a naught x raised power 3 over 2 times 3, 3 times 5. Now what is a4? This is a4 plus a naught x raised power 4 over 2 times 3 times 4, 3 times 5 times 7. So we close the bracket. Now we can see that a naught is common. So let's factorize a naught. So we're going to have 1 here minus x plus x squared over 2 factorial. 2 times 3. Oh, sorry, that's 3 factorial. Minus x cubed over 3 factorial. 3 times 5 plus x raised power 4. X raised power 4 over, this will be 4 factorial. 3 times 5 times 7. So this is our first answer for when x equals to 0. Now when c equals to 1 over 2, now when c equals to 1 over 2, if you remember our equation plus 1, c plus r plus 1, 2c plus 2r plus 1 equals to minus r. Remember this. You remember this equation here. So that is where you're going to put in when c equals to 1 over 2 also. So if I put in 1 over 2 into this equation, so I have 1 over 2 plus r plus 1, 2, 1 over 2 plus 2r plus 1 equals to minus r, right? So I have ar plus 1. 1 over 2 plus 1 is what? What do you have? That's 3 over 2. So you are going to have r plus 3 over 2. Open bracket. This cancel this. So you have 1 plus 1. So you have 2r plus 2 equals to minus ar. Now let's solve this one only first. So you have 2r squared plus 2r, r times this, then plus 3 over 2 times this, we have 3r, because it's just like 3 over 2 times 2r, so 2 cancel 2, so it means 3r, plus 3 over 2 times this, we have 3, equals to minus ar. Now we can see that here we have something in common. 2r is common, r plus 1 left out, plus 3 is common, so you have r plus 1 equals to minus ar. Now we can now write this. We can write it here back. We write it here also. So from here we have r plus 1 equals to r plus 1, then 2r plus 3 minus ar. So we can divide both sides. If you divide both sides by this, we are going to have r plus 1 equals to minus ar over r plus 1, 2r plus 3. Now this is our equation that we're going to be using. Let's take a new page. Coming. Now we're going to start from when r equals to 0. So if r equals to 0, we're going to have a1 to give us minus a0 over 1 multiplied by 3. That's what you're going to have for the first one. Now the second one, when r equals to 1, a2 equals to minus a1 over 2 multiplied by 2 times 1, that's 2, plus that's 5. 2 multiplied by 5. When r equals to 2, so you're going to have a3 minus a2 over, so this will be 2 plus 1, that's 3 times 7. Then when r equals to 3, so we're going to have a4 equals to minus a3 over 4 multiplied by 9. Now let's change everything to a0. So here you're going to have a0 over 1 times 3, 2 times 5, which can be written as a0 over 1 times 2, 3 times 5, in order to put it in factorial. So this and this. Now this will be minus a0 over, this is our a2, then what's a2? This is a2, put it here. 1 times 2, 3 times 5, multiplied by 3, multiplied by 7. So, which gives us minus a0 over 1 times 3, 1 times 2 times 3. So we have 1 times 2 times 3. Those are the lowest. 1 times 2 times 3. Then we have 3 times 5 times 7. That's for that. Now, A3, this is A3. So let's put A3 inside. So you have A naught over 1 times 2 times 3. Then let's go with 4 times 4. Then this other one, 3 times 5 times 7. Then that's it, multiplied by 9. So we've gotten all the value. So remember the equation y equals to x is power c a naught plus a1x plus a2x squared plus a3x cubed plus a4x is power 4. That's what you need. So now when x equals to 1 over 2 now, when c equals to 1 over 2, so we put it there. So we have a naught plus, what is a1? This is our a1. So a1 is minus. So sorry, this one's supposed to be minus a naught over 1 times 3x. Now a2, this is a2, is positive, so that's plus a naught over 1 times 2, 3 times 5 x squared. Now what is a3? a3 is negative, so we have minus a naught over 1 times 2 times 3, 3 times 5 times 7 x is power 3. Now a4, this is a4 and it's positive, so you have plus a naught x is power 4 over 1 times 2 times 3 times 4, 3 times 5 times 7 times 9. Now which a naught is common? Let's factorize a naught. X is power 1 over 2. It will mean 1 here minus x over 1 multiplied by 3 plus x squared over 2 factorial multiplied by 3 times 5 minus x cubed. This is 3 factorial, 3 times 5 times 7 plus x raised power 4. This is 4 factorial, 3 times 5 times 7 times 9. So this is the answer for the second one. Now remember, we have to write both answers together. So now writing both answers together, we are going to have y equals to, we have y to be u plus v. So it will be y equals to the first one that we got, which is a naught x is power 0. Now for the first one, I'm coming. For the first one, we have 1 minus x plus x is power 3 factorial, that is 3 times 2, minus x cubed over 3 factorial. So we have 2 times 3, then this one will be 3 times 5, then plus x4 over 4 factorial, 3 times 5 times 7. Now we need to add it plus a naught x raised power 1 over 2. So this is 1 minus x over 1 times 3 plus x squared over 2 factorial, 3 times 5 minus x cubed over 3 factorial, 3 times 5 times 7 plus this is this plus this, you can write it there. Now y equals to differentiate this and this, we have a not here, a not here. So you put a, you put it as a, the first one as a, and x is power 0 is 1. So we don't need to write that one again. So we have x plus x over 3 factorial minus x cube over 3 factorial multiplied by 3 times 5 plus x raised power 4 over 4 factorial 2 times 3, 2 times 5 times 7. Now this one we put it as b, 1 over 2, x raised power 1 over 2, 1 minus x over 1 times 3 plus x squared over 2 factorial multiplied by 3 times 5 minus x 4 x 3 3 factorial multiplied by 3 times 5 times 7 plus you write the x4 for that. So this is our final answer. Thank you for watching the video. Please do well to subscribe, follow and share. See you guys next time.